Welcome back. In the previous video, we discussed identifiers, comments, and logic values in Verilog. Those topics form the foundation for writing readable and meaningful HDL code. In this video, we move to one of the most important and often misunderstood topics in Verilog, data types. In particular, we will clearly distinguish between nets and variables. In software languages, data types mainly control how values are stored and manipulated in memory. In Verilog, data types have a much deeper meaning. They determine how signals are driven, how values are stored, and what kind of hardware is created. Key warning: using the wrong data type can result in incorrect or unintended hardware, even if the code compiles. Verilog data types can be broadly divided into two categories. The first category is net data types. The second category is variable data types. These two categories represent fundamentally different hardware concepts. Let us begin with net data types. A net represents a physical connection between hardware components. It does not store a value. Instead, it reflects the value being driven onto it by some source. Think of a net as a wire on a PCB. The wire itself does not generate a value, it simply carries whatever is driven onto it. The most commonly used net type in Verilog is wire. A wire must be driven by something. For example, it can be driven by a continuous assignment, a module output, a logic gate primitive. Important rule: a wire cannot be assigned inside an always block. This is because an always block implies storage or procedural assignment. And nets do not store values. Verilog also supports other net types such as tri, WAND, and WO. These are used for special modeling situations like tri-state buses or wired logic. In this course, we will primarily use wire. Now let us move to the second category, variable data types. Variables are used to store values. They retain their value until explicitly updated. This storage behavior makes variables fundamentally different from nets. The most commonly used variable data type in Verilog is reg. Despite its name, reg does not always imply a physical register. It simply means that the signal can store a value in simulation. Whether it becomes a latch, a flip-flop, or combinational logic depends on how it is coded. A reg is typically used inside procedural blocks such as always or initial. This allows us to describe behavior that depends on conditions or clock edges. If you assign a signal inside an always block, it must be declared as a variable type, usually reg. Net versus variable. Let us summarize the conceptual difference. A net represents a connection. A variable represents storage. A net reflects what is being driven. A variable remembers its previous value until updated. Choosing between wire and reg is not a syntax decision, it is a hardware decision. One very common beginner mistake is declaring everything as reg. Another mistake is trying to assign to a wire inside an always block. Both mistakes come from not thinking in terms of hardware. Strong advice: always ask yourself, is this signal a connection, or is it storage? From a simulation perspective, nets and variables behave differently. From a synthesis perspective, they guide how hardware is inferred. Understanding this distinction is critical for writing predictable and synthesizable Verilog code. To summarize this video, net data types represent connections. Variable data types represent storage. The correct use of wire and reg is fundamental to correct hardware design. In the next video, we will extend this discussion to vector data types, parameters, and constants, which allow us to build scalable designs. Please review today's concepts carefully. They will be used in every example from now on. Thank you.